Hello, I'm Matthew Schofield, and together with my group mates Robert Mason and Alex Lamb, we have prepared a presentation regarding Talend Open Studio for data integration. Talend Open Studio is a user interface for data engineering. It's able to support data integration, extract transform load, and extract load transform workloads, and it has a wide variety of data source connectors. Talend Open Studio is able to connect to almost any data repository that you can think of, as well as a variety of software as a service connectors for various things, such as Melissa Data for address validation. Here we can see the wide variety of data source connections that Talend can make. From Google products to Microsoft to Amazon to many niche products. Talend Open Studio is free, as it is open source. It's related to Talend's paid version, the Cloud Data Integration, which charges roughly $1,200 per monthly user and $12,000 per annual user. It is supported on the three major operating systems at various versions, and it requires the Java 8 runtime. Installing Talend Open Studio is easy. Simply go to their downloads page and select your operating system's installer. Once downloaded, run the installer and it's ready in seconds. However, it will not let you know if you have the incorrect Java runtime installed, which is Java 8. If you're not using the correct runtime, the program will act strangely and then eventually crash. I will now demonstrate how to load data and create a simple ETL pipeline in Talend Open Studio. So to start, we will import our data. We go to the metadata tag, and here are various data sources we can connect to. We will use the file delimiter and create a delimited file. We will name it grocery products to connect to our products file. And then we will find that it's saved as a text file. And then here it shows us a preview of the data, and we can see it does contain the headers, so we'll use that in the next step. Oh, and this is Windows. So we will tick this box to include the header, and this is at line 1. A funny part of their interface is it has a drop down for the header selection. And then we will note that the separator is not a semicolon, but we will have to use a custom pipe character. And then next, we now have access to our input delimited file. We can drag it into the ETL pane and select that it is a file input delimited. And now we can also load our intended output file using a component on the components palette here and place it here. Down here, we can select where we want the output file to go. So I will put in this data repository and use this file. Now we will do an aggregation to count the number of products per manufacturer. So we will use tag to get the aggregate row component, and we will connect our grocery products to the aggregator, and in our output file we will edit the schema of the file by adding the columns, the manufacturer, and the number of products. And now we can connect our input to our output. We can group by the inputs manufacturer column and set that as the manufacturer output column. And then we can do the operation for num products we can count distinct product names per manufacturer. And then we can run this ETL pipeline. And then it says it was a success. And if we open the data, we can see that for each manufacturer, we have a count. I will now demonstrate a more complex ETL pipeline in Talend Open Studio. First, there's the pre-job section. These components execute before the rest of the pipeline. This is a MySQL DB connection open component. Here, we connect to a localhost MySQL database. It's important that under advanced settings, we have auto commit set to true. Otherwise, after our ETL executes, they will not be saved. This database connection allows us to set up our output connections to two MySQL tables in our database, the daily transactions and manufacturer stats. I'll talk more about those later. Our input data is our user transactions SQLite database and our products CSV file. These are both sent to a tmap object. The tmap object filters from input data rows to output data rows that can be consumed by these aggregation objects and a filter object here. This is what the tmap object looks like. So this is our SQLite user transactions database fields, and this is our delimited file fields. And then these are mapped each to a main output, main2, and a main3 output. The main output goes to this aggregate object, the main2 goes to this aggregate object, and the main3 output goes to this filter object. So you can control which data is mapped to where using a tmap. This aggregate row groups the user transactions by date and then is able to count the number of items sold, conduct a summation of the revenue, and count the number of distinct customers per day. This goes into our daily transactions table. This aggregate row mostly looks at the products delimited file, and this groups by the manufacturer name, and this counts the number of products carried per manufacturer, and then over the year it totals the sales and the average sale per manufacturer. And we can change the function applied here. So instead of average sales, we could also make this total sales by doing a sum. And we can change the input column here. So instead of sale price, we could do an average base price, and so on. And now I will show the result of these aggregations where they were saved to the output tables. So here is my localhost MySQL database. Here is the daily transactions table, and we see that there are 366 records for the year 2020. And we see that every day we have a daily ID, a date, item sold, revenue, and the number of customers as expected. And the manufacturer stats, where we have each unique manufacturer, the number of products that we carry for that manufacturer, and their total sales for the year, as well as the average sale. And then I will now talk about this filter component, and this takes in a combination of the user transactions information and the products information, and filters where the manufacturer of the product for the transaction equals the Frito-Lay manufacturer. So it outputs all transactions where the product purchased was made by the manufacturer Frito-Lay, and it saves that into a CSV file, Frito-Lay info, which I can show here. So these are all transactions by date with the transaction ID, sale price, SKU, and just to show that the manufacturer is Frito-Lay. And then lastly, we use a post jobs component, and then this connects to a DB close component, and this closes our grocery database MySQL local connection. And then, as you can see here, all these connections have some numbers above them, and these are some indicators about how fast our data was processed. So here we see 291 rows in almost instantly, and this just provides estimates and helps us identify bottlenecks. So for example, the user transactions, reading that in is the bottleneck of this system. Talend Open Studio has many benefits. It allows you to connect to a wide variety of data sources, and its user interface makes it easy to communicate with others about the process of an ETL job. It's also relatively popular in industry, with over 100 testimonials on their site from companies including GE Healthcare and AstraZeneca. Also, Groupon advocates that they use Talend to process 1 terabyte of raw data daily. Talend Open Studio also has some downsides. While its user interface is somewhat convenient for communication, it is also outdated and a little clunky to use. There's very little support, so if you do run into errors, they're often difficult to read and even more difficult to find answers to. And there are also some graphical bugs, such as after deleting an item, it sometimes will appear in another location, and connections from items may point to nothing. Its most compelling features are its portability, where you can easily send ETL workloads to others to understand or improve upon. Also, its mapping, filtering, and aggregation features, which are critical to data engineering, are simple to use. And also, its live speed reporting is interesting to watch and understand bottlenecks in the ETL pipeline. In summary, Talend Open Studio is a user interface for designing ETL workloads. This is a powerful tool with enough experience to understand its strengths and shortcomings, and it offers a wide range of data source connectors. Thank you.